Good evening, everybody, and once again, welcome back to your channel. I'm gonna be your host, Saumil Shah, and in today's video, I'm gonna be showing you how to implement GeoSearch functionality on data lakes or transactional data lakes using Apache Hudi. So the goal for this video is to show you the concept of how we can implement this functionality on data lakes and how we can actually do it efficiently using GeoHash. All right, so without talking any further, let's dive into the lab exercise. So GeoHash are a little complicated, but the key thing to know is that it divides the world into number of squares in a grid. By doing this, we can eliminate most of the data up front and focus on the square our potential targets are in. So in simple language, again, I want to make it very simple, right? Let's say you have a sphere and then you divide the sphere into 4 parts, right? 1, 2, 3, and 4, right? So 4 parts, right? Now, the more you keep dividing, the more rows and columns you add, the finer the grid becomes, right? So does that make sense at least? Now, when I put a point on that grid and I say, hey, what is the location of that point? You will say, it's in this grid and in that particular column. So hopefully that made sense. That is the concept, okay? All right, so here I have the GeoHash length. So as you keep increasing the number, the GeoHash length, the accuracy or the precision is more and more accurate, right? So for example, GeoHash 1, you can locate a large region, example, a country, right? When you choose the GeoHash to 2, you can identify a city, large city. And as you keep increasing, probably let's go to GeoHash 8, you can accurately identify a building or a property. Okay, so that's the key idea. Okay, so now, hey, let's do a lab so that this makes sense, right? So first, I will create a Spark data frame. I have a sample data set which I downloaded from Kaggle. These are all the data set for the coffee shop, Dunkin' Donuts. It's a coffee shop, and I have the data set over here. Now, what I want to do is basically, I would want to compute the GeoHash. It's a 12-digit, okay? So I have some function written, UDF function, which will show you that this is the GeoHash, right? 12-digit. Now, what I want to do is basically from this 12-digit, I want to take the first 6 or 5, depending upon your use case. I'm taking, let's say, first 6 digit. And that will become the partition key for that particular data lake, So I'll explain the concept, okay? So now let me go to the next part. This will make sense. All right, so take a look over here. GeoHash and the hash key. So you see 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so in this case, I've chosen 8. So the first 8 character is the, you can see here, 1, 2, 3, 5, 3 here. I've highlighted it so you guys can see it, right? So that's the GeoHash, and the hash key is the first n characters. You can define that n based on your use case. Now you'll say, yeah, this makes sense, but hey, how is this even gonna help me in searching, right? Well, I'm coming to that in a second, all right? So that's the data set, right? We extracted the GeoHash, then we got the hash key, okay? After that, I upsert the data into the Hudi data lake. As you can see, I call the table as silver store, okay? I have inserted into that. Now here, as you can see, I am creating a snapshot and I'm making sure I'm using the metadata table in Hudi. Data skipping is also set to true, right? And I'm creating a snapshot called stores_temp_view. All right, all that makes sense, but how does the GeoSearch work, right? You still haven't said that. Well, yeah, I'm coming to that. So let's say the user is want to search like nearby coffee shop in a particular location. What you do is you basically calculate the GeoHash from there, right? Now let me switch my screen again. So the GeoHash is 12-digit, right? Okay, agree, it's 12-digit. Now, from that, once the user said, hey, I'm looking for this and this, you calculate the GeoHash, it's a 12-digit, right? Now you take the first 6 or 7-digit or 8-digit, whatever, depending upon use case, the first 8-digit, so you directly know which partition that particular data lives, that particular partition. And then now I can perform radius-based search using Haversine's formula. All right, let me share. I think it's, yeah. All right, so, when user types something, right, we calculate the GeoHash, then we exactly know which partition it is, right? So I tried my best to make this diagram. You see this red box, hash key, right? That's the partition. That's how we have partitioned our data lake, right? So I exactly know that all the records for probably in that locality would be there in this particular partition. So I already eliminated most of the records here, right? I already eliminated that because I know exactly which partition this record belongs to. Now in this record, in this partition, there could be like about bunch of records, right? Now you have a smaller data set, and now you can compute the Haversine formula on the small filtered data set and compute the radius search and grab the nearby items. You see what I'm saying, guys? All right. So let me show you the code. Hopefully made sense. So this is the target lat and long, precision 8. This is, again, you can change it. Precision basically means how many characters you need in the hash key, right? So that's that, right? So look what we do. We basically compute the hash, geo hash, which is 12 digit, and then we grab the first 8 characters, okay? And then again, simple Spark SQL, right? I'm selecting the name, the address, the geo hash key, lat and long. And then what I said, I want to select everything from this particular view where the hash key is equal to this, meaning over here, right? Once I compute the hash, I know those records, the similar or nearby items will be in this particular folder or partition, right? So makes sense. And then the math equation that you see here is the Haversine's formula. So I say, give me items where, my distance is, probably less than equal to my search radius, right? So if I run this, hopefully, I think I have a typo. I need to run my previous cells. So I'm gonna quickly run them. So let me run these cells. And then I will run my snapshot. And now watch what's gonna happen, okay? So see, we got that particular items in a very efficient way. I'm gonna do it once again. I'm just gonna explain you what just happened. So whatever the user is trying to search, right? Whatever location, maybe say, hey, I wanna get something in Stamford. If he's passing a natural query, you can use OpenAI and grab the lat and long or whatever API and just get the lat and long. Once you have the lat and long, convert that into a geohash, which is 12 digit. Now from that, the first extract the first 6 or 8 characters depending upon your use case, and now you know that item to that location would be in that particular partition, right? Once you already knocked out a lot of records, now you only have these many records because you're directly saying that, hey, give me everything in that partition. Now within that partition, now perform a Haversine formula and you can get all the nearby stores or whatever item that you're trying to search. That's how you can implement search functionalities on data lake. The entire exercise is also on my blog section, so feel free to try this out. Again, it's a really amazing to see how everything works together, right? So let me see if I can quickly show you Saumil Shah 1995 blogspot.com here. So if you come here, see, I tried my best to explain as much as I can, and everything is explained. You can see everything, every single step. So first I calculate the geo hash, then I compute the hash key, then I upsert the data into Hudi data lake, and then the search process, I explained that through a small diagram as well. So that's all I have for the video. I hope you have enjoyed, and the best way to support me would be to like the video and share the video with your coworkers and colleagues. That's all I ask in return. If you have questions, I'll be more than happy to answer. But until then, I'll see you in the upcoming next video.